Hello everyone, welcome back to my channel. In this video lecture, we will cover a new chapter of chemistry, that is some basic concepts of chemistry. So, what is chemistry? It is a branch of science that deals with the composition, structure, and properties of matter. Chemistry is called the science of atoms and molecules. There are different types of branches of chemistry: organic chemistry, inorganic chemistry, physical chemistry, analytical chemistry, and biochemistry, and nuclear chemistry. Then properties of matter and their measurements. Every substances are unique or characteristics properties. These properties can be classified into two categories: physical and chemical. Physical properties are those properties which can be measured or observed without changing the identity or the composition of the substance. Example: color and odor. Then chemical properties are characteristic reactions of different substances. These include acidity or basicity, etc. Many properties of matter such as length, area, etc. are quantitative in nature. Metric system was based on decimal system. Then the International System of Units of SI. The International System of Units, abbreviated as SI, was established by 11th General Conference on Weights and Measures. The SI unit has 7 base units: length meter, mass kilogram, time second, temperature Kelvin, amount of substance mole, electric current ampere, luminous intensity candela. Then mass and weight. Mass of a substance is the amount of matter present in it, while weight is the force exerted by the gravity on that object. Volume has units of length cube. So volume has units of meter cube or centimeter cube or decimeter cube. Density of a substance is its amount of mass per unit volume. Temperature, these are common scales to measure temperature. Celsius, Fahrenheit, and Kelvin. Kelvin is the SI unit of temperature. Fahrenheit equals to 9 upon 5 degrees Celsius plus 32, and Kelvin equals to degrees Celsius plus 273.15. Note: temperature below 0 degrees Celsius are possible in Celsius scale, but in Kelvin scale, negative temperatures are not possible. Then scientific notations are in which any numbers can be represented in the form of n into 10 raised to the power n, where n is an exponent having positive or negative values, and capital N can vary between 1 to 10. Precision refers to the closeness of various measurements for the same quantity, and accuracy is the agreement of particular value to the true value of the result. Significant figures. The reliability of a measurement is indicated by the number of digits used to represent it. To express it more accurately, we express it with digits that are known with certainty. Then rules for determining the number of significant figures. All non-zero digits are significant. All zeros between significant in case it comes in between non-zero numbers. Zeros at the beginning of a number are non-significant, and all zeros placed to the right of the number are significant. In exponential notations, the numerical portion represents the number of significant figures. The decimal point does not count towards the number of significant figures. Rounding of figures. The rounding of procedure is applied to retain the required number of significant figures. If the digit comes after the desired number of significant figures happen to be more than 5, the preceding significant figure is increased by 1. If the digit involved is less than 5, it is neglected and preceding significant remains unchanged. If the digit happens to be 5, the last mentioned or preceding significant figure is increased by 1 only in case it happens to be odd. Then dimensional analysis. During calculation, generally there is a need to convert unit from one system to another. This is called factor label method or unit factor method or dimensional analysis. Then elements. An element is the simplest form of matter that cannot be split into simpler substance or built from simpler substance. Compounds is a pure substance made up of two or more elements combined in definite proportion by mass, which could be split up by suitable chemical methods. Characteristics of compounds. Compounds always contain a definite proportion of the same elements by mass. The properties of compounds are totally different from the elements from which they are formed. They are homogeneous. They are broadly classified into inorganic and organic compounds. Then mixture is a combination of two or more elements or compounds in any proportion so that the components do not lose their identity. Homogeneous mixture have the same composition through the sample. The components of such mixtures cannot be seen under a powerful microscope. They are called solutions. Heterogeneous mixtures consist of two or more parts which have different compositions. These mixtures have visible boundaries of separation between the different constituents. Now, laws of chemical combination. First, law of conservation of mass. It states that mass or matter can neither be destroyed or created. Then, laws of definite proportion or law of constant composition states that a chemical compound always consists of the same element combined together in the same ratio, irrespective of the method of preparation on the source from where it is taken. Law of multiple proportion states that when two elements combine to form two or more compounds, then the different masses of one element which combine with the fixed mass of the other bears a simple ratio to another. Gay-Lussac's law. According to this law, when gases combine or are produced in a chemical reactions, they do so in a simple ratio of volume, provided all gases are at same temperature and pressure. Then Avogadro's law. According to this law, equal volume of gases at the temperature and pressure should contain equal numbers of molecules. Dalton atomic theory. All substances are made up of tiny, indivisible particles called atoms. Atoms of the same elements are identical in shape, size, mass, and other properties. Atoms of different elements are different in all respects. Atom is the smallest unit that take part in the chemical combination. It combines with each other in simple whole number ratio to form compound atom called molecules. It cannot be created, divided, or destroyed during any chemical or physical changes. Atoms and molecules. The smallest particle of an element which may or may not have independent existence but is the reactive unit of a reaction is called an atom, while the smallest particle of a substance which is capable of independent existence is called a molecule. Molecules are classified as homoatomic and heteroatomic. Homoatomic are made up of the atoms of the same element. Heteroatomic are made up of atoms of the different elements. Atomic mass unit. One atomic mass unit is defined as a mass exactly equal to 1/12 of the mass of one carbon-12 atom. Today, AMU has been replaced by mu, which is known as unified mass. Atomic mass of an element is defined as the average relative mass of an atom of an element as compared to the mass of the atom of carbon-12 taken as 12. Gram atomic mass. The quantity of an element whose mass in grams is numerically equal to its atomic mass. In simple terms, atomic mass of an element expressed in grams is the gram atomic mass or gram atom. Molecular mass of a substance is defined as the average relative mass of its molecule as compared to the mass of an atom or C12 taken as 12. Then gram molecular mass, a quantity of a substance whose mass in grams is numerically equal to its molecular mass. Formula mass is the sum of atomic masses of the elements present in one formula unit of a compound. Mole concept is defined as the amount of substance which contains the same number of chemical units. A mole represents a collection of 6.022 into 10 raised to the power 23 chemical units. The mass of 1 mole of a substance in grams is called its molar mass. Percentage composition. The mass percentage of each constituent elements present in any compound is called percentage composition. Empirical formula represents the simplest whole number ratio of various atoms present in a compound. The molecular formula shows the exact number of different types of atoms present in a molecule of a compound. Then relationship between empirical and molecular formula. N equals to molecular formula mass upon empirical formula mass. Limiting reagent, the reaction which get consumed first or limits the amount of product formed is called as limiting reagent. Reactions in solutions, the concentration of a solution can be expressed in one of the following ways: mass percentage, mass of the solute in grams per 100 grams of the solution. Volume percent is the number of units of volume of a solute per 100 of units of the volume of solution. Molarity of the solution is defined as the number of moles of solute dissolved per liter. It is denoted by symbol capital M. Measured in molarity can change with the change in temperature because solution expand or contract accordingly. Then molarity of a solution is equal to mass of the solute upon molar mass of the solute into volume of the solution in liters. Then molarity equations. To calculate the molarity, to calculate the volume of a definite solution required to prepare solution of other molarity is equal to M1 V1 equals to M2 V2. Molarity is defined as the number of moles of solute dissolved per 1000 gram of solvent. Mole fraction is the ratio of number of moles of one compound to the total number of moles present in the solution. So this much for today's video. Hope you liked it and you understood it and it helped you. Thank you for watching my video. Please like, share and comment, and don't forget to subscribe my channel. Till then, thank you.